Okay, this lesson is on finding the derivative using the shortcut method. We're going to explain later why this works. This is just an explanation of how to take the derivative using the shortcut method. Now remember, the original function could be like time and height. I plug in the time, and then I can find out the height of the ball. That would be the original function. Finding the derivative function would tell me the velocity of a ball at a certain time, the velocity of the ball. So if we have the original, how can we convert that to the derivative function? And here's the how-to. So our first example, our function is x to the fifth. So here's how the shortcut works. Again, we'll explain why it works later on. For every derivative, here's how it works. The exponent is going to move to the front, variable stays, and we always subtract 1, so we get 4. To show that this is the derivative, we put f prime, that shows it's the derivative of x. So the derivative is 5x to the 4. Now I know that looks simple, but let's make sure we understand. Exponent moves to the front, then we subtract 1. Exponent moves to the front, and we always subtract 1. Now we're going to do a series of problems, but we're always going to do the same thing. Exponent will go to the front, then subtract 1. Next example. Well, to make sure we understand everything, let's fill in that x is really x to the 1. X is really x to the 1. So, if I want to take the derivative of that, the 1 would go to the front, rewrite the x, then we always subtract 1. Well, what's 1 minus 1? 0. X to the 0 is 1, so we really just get 1. So the derivative of x is 1. Now, let's make sure we understand that. I'm going to throw in another example. Let's say we have the original function is 7x. Okay, let's go through the same steps. There's a 1 here. Now we'll do more of these in a second, but the 7 will stay. The 1 goes in front. X, subtract 1. 1 minus 1 is 0. X to the 0 is 1. So we're just left with 7 times 1, which is 7. So we're kind of developing a pattern here. If I had 1x, the derivative is 1. If I had 7x, the derivative is 7. So if I had the derivative of 10x, I already know the answer is going to be 10. I can work it out because there's a 1 here. Derivative, the 10 will stay, the 1 goes in front. 1 minus 1 is 0, that becomes 1, and then 10 times 1 is 10. So we developed a pattern. Derivative of 1x, 1. 7x, 7. 10x, 10. So the derivative of 100x would be 100. The derivative of negative 5x would be negative 5. Derivative of negative 1.23x would be negative 1.23. Now, next one. We've already kind of talked about this, but just to remind you, if there's a number in front, we leave the number in front. If there's a number in front, we leave the number in front. The 4 would go in front. Subtract 1, we get 3. Now, you're probably already seeing a shortcut. The exponent moves in front, and we just multiply these. So 3 times 4 is 12 x to the third. 12 x to the third. Okay? Now, this works with all numbers, fractions, decimals, negatives, positives. It still works. So here, the negative 4 will stay in front, 3.2 will come down, subtract 1. Even though it's a decimal, the rules are the same. Even though it's a decimal, the rules are the same. So 3.2 minus 1 is 2.2. Fractions, decimals, all done the same way. And then negative 4 times 3.2 is negative 12.8 x to the 2.2. Every problem has been consistent. Exponent goes to the front, subtract 1. If there's a number in front, you multiply. Now, e. E looks a little confusing because there's no variable here, but I could put x to the 0 to show there's no x's there. And if I follow my steps, 0 would go to the front, 0 times 5 is 0, anything times 0 is 0, we find that the derivative of 5 is 0. Well, to keep that pattern going, what would the derivative of 6 be? 0. Derivative of negative 7 would be 0. The derivative of any number, fraction, decimal, as long as it's just a number, would be 0. And the explanation is, you could put that x to the 0 here, 0 goes to the front, anything times 0 would be 0. Now, there's a certain way we like to see the problems. We like to see, similar to the first one, x to the 5th, or to the third one, 3x to the 4th. We're not as happy about seeing a fraction. So remember from your algebra, if I have 1 over x to the 3rd, that can be moved up to x to the negative 3. So that can be moved up to x to the negative 3. I haven't taken the derivative yet. I have not taken the derivative yet. I just rewrote it to make it easier to take the derivative. So that's a rewrite. Again, remember your exponents, if you move them up, it becomes negative. So the derivative, again, even though it's a negative, does not matter. Same steps. Negative 3 goes to the front. Subtract 1. Be careful. Negative 3 minus 1 is negative 4, not negative 2, negative 4. That is the derivative. And then we're just going to simplify. How do we make a negative exponent positive? Move it to the denominator. How do we make a negative exponent positive? Move it to the denominator. Again, we don't move the negative 3, we just move negative exponents. We move negative exponents. The derivative would be this.